All right, team, here we go. We're going to take a look at 712 today. And again, we kind of referenced this yesterday, but again, if you don't know what that sine graph looks like, it's not a big deal, but it's just going to be this type of a thing. That's what you're going to be focusing on here. We'll see more of it as we get going here, but focusing on the sine graph. Let's see what that looks like. So here we go. Of course, a long story problem here, and here's what's happening. So basically, you've got these two kids, and they are racing to go on this new ride called the Screamer. And what happens is, as you can see in this picture here, is that they're kind of on this circle, and they're going kind of down and around. And it's supposed to be the scariest ride on Earth. Half of it is below ground in a very dark and murky pit with water at the bottom, and then the other half is above ground. So let's see what that looks like more. For the record, there is more to the story problem. If you want to read it, you can certainly pause the video and take a look, but I'm not going to read all that. That said, I should note this thing here. So the ride rotates 15 degrees to load and unload the next set of riders. That's a key piece of information that you will need out of that, though. And also the key information is that they had to build it quick to get it done in time for summer, and Renee and Antonio get stuck, and they have to climb vertically to the ground level uh, to get up and out. Okay, so now we're going to start to look at what this actually does. So all this stuff about your teacher is going to provide all this transparency, blah, blah, blah. I am not going to do that. You're going to check it out with the student e-tools. So there's this one for B and this one for A, and both these are really good and really useful. I'm not going to show them live here, but I'll show you screenshots of them and kind of what's going to happen. Okay, so here, using the transparent ruler, yep, we're not doing that, but we're gonna model these 16 different possible seat positions to see how the riders need to escape, because in theory, they should be at all different spots around this around this ride. And so when you've got this up in Desmos, you've got this slider here, and you can rotate this. And as you rotate that, it's going to change this triangle position that'll be something like this. And what is good about that, is that basically it's kind of modeling this unit circle is really what this is getting to here. So basically here, when you've got this A is at 30, so it's at a 30-degree angle. Your measured height of the Y. So Y axis is what's going up and down, of course. So then the Y axis would be this height that it's telling you right there. So this height is 0.5 from the ground, which course starts to correspond with what you need from the actual story problem there. So the problem says that it's got a radius of 100 feet, and they're telling us here that that a model height of one unit corresponds to 100 feet. So point 0.5, that would be equal to 50 feet. Sorry, you can't really read that 50. I should have zoomed in and wrote this here. Let's try this again. So the point 0.5 would be equal to 50 feet. And so that's telling you the distance from the actual like height there. Okay. Okay, so now we need to translate that 50 feet to the actual height above or below. Of course, this is above because we're above it. We are there, so that'd be that positive 50 feet. As you start to spin this thing, you could make the same triangle going this way, and it just have that kind of negative 30 um, degrees backwards, or you can think about that as 330 degrees. Going this full distance would be 330 degrees. So it doesn't really matter how you write that. If you want to write that as a negative 30, if you want to write that as 330, both of them end up being that same point. Again, you're going to get that 0.5, which is 50 feet. And then that's going to end up being 50 feet below. So I'm just going to show that with just a negative 50 there. And so that's kind of what they're trying to get you to do, is just kind of fill out this table and see what the thing looks like I think if you don't want to make the whole table, I don't think you have to see every single value there, but it is kind of nice to start to notice the patterns specifically. Like, hey, we already noticed that at 30 degrees, hey, it seems to match this one. Hint, hint, if you get it out here where there's 30 degrees from 150 to 180, that's another 30-degree angle here. And this is also going to be zero point 0.5. And so you can start to find some different patterns there. And that's really what they're trying to get you to do there. And the reason why I'm saying you don't have to go real intense with this is because they kind of have this data ready for you to find those patterns in part B. So let's take a look at part B. So part B now, we've gotten into the second Desmos thing, and now we're just going to graph all those points. So check this out. So here are all those points. Of note here when I say this, that here are all those points. Here are all the points that I already like plugged in and got. When you pull up the student version, it doesn't give you all of these Y values. So these are just the ones that I have already gone through and calculated and added into the page here. So you would have to go through and add all those points to be able to see that. And here's that zero point 0.5 thing that we're focused on with that 30 um degree piece. And then as you start to go down that data, you'll start to see some patterns or some numbers kind of ending up repeating. So for example, here's one of your repetitions is that, hey, the height at 75 degrees and at 105 ends up being that same 9.66. And and that's what's kind of creating this sort of like pattern or this cycle, that those two things are kind of matching in height, those two things are kind of matching in height, and not kind of, but exactly those two things are kind of matching in height there. And that's what's creating your cycle. And that's what's kind of going there. So then you go through and you graph it. That's what they already did with all these points. And it says, suppose we were to add 20 more data points to your table. What shortcuts could you use? Well, I would just start to do some of my repeating values that I see happening here. Just basically going through, and this is why we call it a cycle, is because hey, it's going through this cycle, and by the time you hit back here, all of these initial values that are coming out front here are just going to repeat themselves now right here, and we're going to get that same cycle there, just like you'd get the same cycle down here then going that way. So you'll just start to see that cycle and just going and repeating, and that's kind of the whole key piece there. I think that the Desmos stuff there is worth it to kind of play with and kind of mess with some, just to really kind of help you get your head around it. Okay, so jumping forward in 713 now, we're gonna. This is a new parent function. So these cycles are going to be a new parent function to add into our other ones. Like we've got the parabola ones, you've also got the line, you've got the exponentials, all that type of fun stuff. So we're going to take a look at these functions here, and I kind of already stole this thunder, but this is what's going on here. It says with your team, write an equivalent. Or excuse me, write an equation and use it to calculate the height of the triangle. Well, to calculate the height, this side, well, I'd probably use sine. I'd go sine, which is opposite, and we call that x, over adjacent, or excuse me, over hypotenuse, which is 1. But I know my sine. My sine is 40. So I'd say that sine of 40 is equal to x over 1. So then I just need to clear my 1, which is clear. So I'd end up that sine of 40 is equal to x. And so when you look at that, it says, does the calculated escape height seem reasonable with the data that you collected in 712? They're trying to draw that comparison to what you're finding here with this triangle, and it, it doesn't make sense there. And in this case, yes, it does. And so we're going to start to figure out what this new parent function looks like and get some rules around it in part B. And the big payoff there is that it's just, whoops, I guess I need a pen, is that it's just sine of theta. Theta is the symbol that we're going to use to basically talk about the angle here. So whatever your angle is, you take the sine of that, and that's going to tell you what your height is from the escape, what that x value is over 1 from the to escape from this ride that has broken down. Okay, team. So this next part here is just asking you to enter this all into your graphing calculator. So your TI-84 plus graphing calculator there. Here's the thing, as of 24-25 school year, um, the state has just added Desmos calculators as well as the TI calculators. It will be available on your MCA test. So I'd say whichever one you feel more comfortable with. Personally, I would strongly indicate towards Desmos. I do think that there are specific things with the TI that can be done well, that can be helpful. In my opinion, this is not one of those things. Most things I'm going to end up in Desmos because it's going to be a little bit more natural. It's going to be a little bit better. Um, and that's that. But this is where if you are more partial to the TI calculator, practice typing this stuff into your TI calculator, setting that window so that you don't just see this um, and and then it cuts off. Practice expanding that window so that you can see more of that. If you need instructional help about that, feel free to ask me because it's just easier to do in person and just kind of show you. It's not super difficult, but it is something that's just easier to do in person. So this whole thing here, we've kind of already done this on the Desmos side, so I'm just going to let that roll. If you do want to see it on the TI side, please come and ask me individually. Okay, so last problem here. So our friends are back home, and they decide, of course, to do some math because that's what I would do after a terrifying experience. So they have these 5 seat positions here that are all in the first quadrant, and they drew them onto this mock screamer here. And basically, what this is asking you to do is to label each triangle with its calculated height. So basically, you need to find out what is the sine of 15. What is the sine of 30? We already know that one. That's 0.5 because that's that example that we're doing. What's the sine of 45 and so on and so forth. So I'll give you a second to pause the video and then I'll show you my chart of that here in just a second. All right, team. So here is my list of data, and I just pulled it from the previous problem from 712 there. Just took and did all of those different values. You can see it. I'll zoom in on it right there. Should see this kind of arcing thing where it kind of goes up here and then goes down and goes down around. So we see that. So we see that kind of repetition there, and that just gets you each of those angles. Last thing here in part B, just asks you to draw the 5 triangles that would look like that. Well, they should kind of be in a similar spot. So I'm going to end up with the same type of 5 triangles here going down the unit circle. And of course, that's exactly 5. It's not like I missed one or anything like that and made 5. But but to back up here, this is the whole art of this whole thing here is the unit circle is saying, hey, I can take this angle here, and this angle is going to be the same as one of my angles over here, as over here, as over here, and there's all kinds of different things that I can do in different quadrants in the circle there to find out what is going on. So that's kind of where we are going with all this, and that's why we are talking about what these things do and how they go together in each of those pieces. And then, of course, in part C, it just asks you to do what I talked about there. We're just in that unit circle. You've got those triangles that are drawn down here as well, and down here in the 2 quadrants. And what you'll find out is that it's just that you'll see that same like 30-degree angle here that was that point 0.5 will exist in 150 degrees here, and that'll be 0.5, and then it'll exist in for some reason I can't think what this math is 210 degrees here, and then 330 degrees here, and they'll all have that same height of 0.5, and they'll all be that 30-degree angle based off of right here, but it ends up being these different degrees as you go around the unit circle. And so you start to see that thing that is just kind of looping there. So that is the whole point of today, just to kind of recognize those patterns and start to see that, oh, there is a pattern that just if I take this quadrant, I can get the same numbers in this one and in this one and in this one. And we'll start to explore more about that as we move on. But that's it for today. Check out the review and preview and let me know if you have any questions.